Okay, let's take a look at an example. This is not on your notes, but we're just going to look at this together. Okay, so if the outside has a solution, okay, we'll put the cell in a beaker. Okay, the outside of the cell has a solution of 65% solutes, and inside is 25% solutes inside the cell. So if it was out of 100, so if the outside was out of 100, how much water would there be? So if 65 was solute out of 100, there'd be 35% of it would be water outside. Now in this case here, if 25% was inside the cell with solutes, how much would be water? It would be 75% water. Now let's take a look at where water is going to move. Where is there a high concentration of water? Well, we have here 75% is inside of the cell compared to outside where there's a low concentration, 35%. So all that water is going to want to move out. Now go ahead and do this on your own paper. Okay. Where is there, now let's take a look at the solutes. So if there's 30% water outside, 70% would be solutes. How about inside? 60% water, and out of 100, the rest would be solutes, 40%. But remember, we're taking a look at water moving. Which way will water move? Well, what's given is 60% of water is inside. There's more water inside than there is outside. There's only 30% water outside. So remember, water likes to move where there's a lot of water to where there's not a lot. So that water is going to move out. Now let's take a look at a different cell, a cell that's put into a different solution. Now it's hypotonic solution. Now if you see, okay, remember the solutes are all of the black molecules that are there, okay. Where is there a high concentration of solute molecules? Where I can see more solutes on the inside compared to the outside. The outside has a low concentration of those solute molecules. Okay, so I want you to label where there is more and less solute concentration. Now let's do this for the water concentration. Where is there more of those Mickey Mouse looking molecules or water molecules? Well, if I see there's more water molecules outside and there are fewer water molecules inside. So make sure you label there's a high concentration of water outside and a low inside. Now knowing where water moves, remember we're only going to be taking a look at osmosis. Water likes to move where there's a lot of water molecules to where there's not a lot. And in this case there's a lot more outside, and that water is going to move inside because there's not a lot of water inside. So make sure you draw the arrows to show that the water molecules are moving inside. Now, when a cell will go ahead and move water inside, because there's more water outside, that is called a hypotonic solution, where there is a solution where there's solutes and water, but there's not a lot of solutes and there's a high concentration of water outside of the cell. Now, taking a look at your notes, okay, you can, like I said, you can either draw what's happening when an animal cell is placed into a hypotonic solution, or you can write it out. Now here, a normal cell will have water going in and out at the same time. But if it was placed in a hypotonic solution, there's a lot of water outside compared to inside, so all that water wants to go in, and the water is going to get bigger, or maybe it's going to burst. Okay? And these are for animal cells. I know these are animal cells because they are circular. Now take a look at what happens with a plant cell. Again, you can draw this out or write it out. Now, in a plant cell, okay, the water will move in and out just regularly. But if it's placed in a hypotonic solution, if you can see, it gets a little bit bloated looking, okay? But it doesn't burst like an animal cell because it has the extra layer of the cell wall for protection there. So it prevents it from bursting. Now my memory clue for this would be hypotonic. Remember, it lets water in, making the cell a little bit bigger. So I think hippo, because hippos are big organisms, okay? And if you place a cell in a hypotonic solution, it's going to get bigger. Let's take a look at an example, a practice problem. Okay, so I want you to pause the video and fill in the missing solute concentrations, and then draw an arrow to show which way the water will move. So if there is 80% water outside, how much solutes are outside? There's 20% because it's out of 100. And for the cell, there's 5% water, so the rest would be solutes, 95%. Now remember, we're talking about osmosis, so which way will the water move? Well, the water is going to move where there is a lot of water outside compared to inside. There's not a lot of water, so all that water wants to move in. It's going to make the cell get bigger. Now the last one that we're going to take a look at is when cells are put in an isotonic solution. Now if we take a look at this, okay, and we see that the amount of the water molecules, or a concentration of them, is equal to what's inside. Okay, and the same thing with the solutes. The solutes outside, okay, the concentration is equal to inside. So with the equal amounts of water and solutes inside and outside, what's going to happen to the water moving? Well, since there's even amounts of water in and out of the cell, water is going to move in and out at the same time. So it's not going to shrink and shrivel up, or it's not going to go ahead and burst, because water will move at the same time into and out of the cell. So what the definition is when a cell is placed in an isotonic solution, the solution has equal amounts of solutes and water in and out of the cell. So let's take a look, because you're either going to draw this out in your notes, okay, of what happens to a cell when it's placed in an isotonic solution, or you can write it out. Of these diagrams, here are animal and plant cells, which one would be in an isotonic solution? Now we can see that diagram B. This is what you would either draw, the animal or plant cell. We see that water is moving in but also out at the same time for both plant and animal cells. So they don't really change their shape. They're not going to go ahead and get water taken in to be bloated or be bigger. They're not going to have water be taken out to shrivel up. They're just going to kind of stay the same. Now my memory clue for you is, okay, think of like an isosceles triangle. An isosceles triangle has two equal sides. So you can think iso equal or isotonic. That means, okay, there's equal amounts of water and solute in and out of the cell. So it stays the same size. So let's take a look at our last problem here. Make sure you go ahead and write down the missing solute concentration and draw an arrow to show which way the water will move. And in this case, there is 78% water inside and outside of the cell. So that means their solutes are going to be even. They're going to be 22% solutes. So which way will the arrows move to show the water? Okay, since there's equal amounts of water, they're going to move in and out at the same time.